Imagine this. You start digging in your backyard. Not for a pipe, not for a basement. You keep digging, straight down, forever. And the goal is insane. To reach the other side of Earth. At first it sounds like a cartoon idea. But the moment you ask, what would actually happen? You open one of the most fascinating science stories on Earth. Because the deeper you go, the more Earth stops being ground. And starts becoming something completely different. In the beginning, digging feels normal. You hit soil, clay, rocks, groundwater. You might think, okay, this is possible. But here's the first truth. Earth's surface is only a thin skin. The part we live on is called the crust. And compared to the size of Earth, the crust is shockingly thin. If Earth were the size of an apple, the crust would be thinner than the apple's skin. That means we are living on a fragile shell covering a planet-sized furnace. Now let's go deeper. As you dig down, temperature rises. This is called the geothermal gradient. Near the surface, the average increase is around 25 to 30 degrees Celsius per kilometer. That means, at 1 kilometer, it can already feel hot. At 3 kilometers, it becomes dangerous. At 5 kilometers, machines start failing. At 10 kilometers, you're in a heat nightmare. And here's something real and important. The deepest hole humans ever drilled is called the Kola Super Deep Borehole. It reached about 12.3 kilometers. That's the deepest humans have ever gone. And even there, the temperature was around 180 degrees Celsius. So before you even scratch the surface of Earth's interior, you are already in conditions that can destroy equipment and kill a human instantly. Now let's talk about the most underestimated problem. Pressure. Every meter you dig down adds more rock above you. And rock is heavy. Very heavy. The deeper you go, the more the Earth squeezes the tunnel walls. At some depth, the rock begins to behave like a slow liquid. Not because it is melted, but because under extreme pressure, solid rock can flow. This means your tunnel would not stay open. It would collapse. Even if you built strong walls. The deeper you go, the more impossible it becomes to resist. Earth doesn't just sit there. It pushes back. So in part 1, we learned something shocking. You don't need to reach the core to fail. Even a few kilometers down, heat and pressure become extreme. But now comes the next big twist. Because even if you had a magical drill, what exactly would you hit inside Earth? Is it all molten lava? Is there a giant underground ocean of fire? Or is the inside of Earth something completely different? In part 2, we will enter the real layers of Earth. And the truth is more surprising than the movies. Most people imagine Earth like this. A thin crust. Then a huge ocean of lava. Then a burning core. But that picture is wrong. Yes, Earth is hot inside. But Earth is not a hollow lava ball. In reality, Earth has layers, and each layer behaves differently. If you dig deeper, you don't fall into a lava sea. You enter a world of solid rock under insane pressure, slow-moving plastic mantle, liquid metal, and finally, solid metal again. And that's where the story becomes truly mind-blowing. The first layer is the crust. This is where continents sit. Oceans sit. Humans live. The crust is thin compared to Earth's size. Typical thickness. Oceanic crust, 5 to 10 kilometers. Continental crust, 30 to 70 kilometers. So even if you drilled the deepest hole ever made, 12.3 kilometers, you still wouldn't even reach the mantle in most places. You'd still be in the crust. That's how huge Earth really is. Below the crust is the mantle. This is where things get strange. The mantle is mostly solid rock. Not liquid. But it's extremely hot and under massive pressure. So over long periods of time, mantle rock behaves like thick honey or soft plastic. It can slowly flow. This is one reason continents move. This is also why your tunnel would fail. Because deep underground, rock does not stay rigid forever. It squeezes. It creeps. It closes holes. So even if you dig a tunnel, Earth will slowly heal it by crushing it shut. Now comes the most shocking part. Deeper down, you reach the core. Earth's core is not rock. It is mostly iron, nickel, and it has two parts. Outer core, liquid metal. This layer is liquid. It's like an ocean of molten iron. And this is extremely important because the outer core is the reason Earth has a magnetic field. The movement of liquid metal generates Earth's magnetism. That magnetic field protects us from deadly solar radiation, cosmic rays, atmospheric loss. Without it, life on the surface would be much harder. Inner core, solid metal. Now here's the part that shocks most people. Even though it's hotter, the inner core is solid. Why? Because pressure is so extreme that it forces iron atoms into a solid structure. So Earth has liquid metal around, solid metal in the center, a burning hot solid ball, like a star trapped inside a planet. So now you know the truth. Earth is not a giant lava cave. It is crust, mantle, liquid metal, solid metal. And every layer becomes more hostile. But now comes the most exciting part of this story. Because many people ask, if I dig through Earth and jump in, will I fall out the other side? In part 3, we'll explore the famous idea, the gravity tunnel, and what would actually happen to your body if you tried it. Now let's do something fun. Forget drills. Forget heat. Forget collapsing rock. Imagine you have a magical tunnel. Perfectly straight. Perfectly smooth. Perfectly open. From one side of Earth to the other. Now you stand at the edge and jump in. The question is, would you fall all the way through and fly out the other side? Most people think the answer is yes, you fall through and shoot out like a cannon. But real physics gives a much more interesting answer. On the surface, gravity pulls you down with full force. But as you go deeper into Earth, something changes. Inside Earth, the gravity from the mass above you cancels out. Only the mass below you pulls you. So as you approach the center, gravity becomes weaker. At the exact center of Earth, gravity becomes zero. That means you accelerate at first. Then you accelerate less and less. And at the center, you are weightless for a moment. Then you pass the center. And gravity starts pulling you back toward the center from the other side. So you slow down. And here's the key. Gravity never pulls you outward. It always pulls you toward the center. Now for the most famous part of this idea. In a perfect tunnel with no air resistance, the motion is similar to a pendulum. Physics shows that the travel time from one side of Earth to the other would be about 42 minutes. Yes. In theory, you could travel from one side of the planet to the other faster than most airplanes. And if there was no friction, you wouldn't stop. You would reach the other side, come back, pass through again. Forever. Like a human yo-yo through Earth. Now let's add reality. A tunnel through Earth would not be empty. It would contain air. And air resistance would become brutal. As you fall, speed increases. Air pressure increases. Heat from friction increases. You would lose energy. So instead of reaching the other side, you would slow down and stop near the center. In fact, you'd end up floating in a deadly environment. No oxygen supply. Extreme heat. Extreme pressure. So in the real world, even if the tunnel existed, you wouldn't make it through. So now we know. In perfect physics, white heavy checkmark 42 minutes to the other side. In real physics, crossmark you stop near the center. But now comes the most terrifying question. What would happen while you are digging? Because as you dig deeper, Earth fights back with heat, pressure, toxic gases, water floods, and violent rock explosions. In part 4, we'll explore the real dangers that would destroy your tunnel long before you go deep. The biggest mistake people make is imagining Earth as stable. It's not. Even if you could dig perfectly, the hole would not stay open. Because deep underground, rock behaves like a powerful hydraulic press. As depth increases, pressure increases, rock becomes less brittle. The tunnel walls begin to squeeze inward. At some point, the rock will close the tunnel like a crushed straw. And here's the scary part. You don't need to reach the mantle for this. Even deep mines today face tunnel collapse risks. That's why real mines use thick supports, steel reinforcements, constant monitoring. Now imagine a tunnel thousands of kilometers deep. It's not just difficult. It's physically impossible. Heat is not a small problem. Heat is a wall. As you go deeper, temperature rises so high that humans die, machines fail, metals weaken, electronics break. Cooling becomes impossible. Even at a depth of 12 kilometers, the deepest drilling, the heat was already extreme. Now imagine 50 kilometers, 500 kilometers, 2,000 kilometers. The deeper you go, the more the environment becomes like a furnace. And unlike the surface, you can't release heat. You are surrounded by hot rock on all sides. So your tunnel becomes a heat trap. Now comes the danger most people don't expect. Water. In the upper crust, there are cracks in porous rock filled with water. If your tunnel goes deep enough, you can hit pressurized groundwater, underground water pockets, superheated water. At high temperatures, water becomes steam. And steam expands violently. This can cause sudden blasts, rock fragmentation, tunnel destruction. Also, deep underground you can encounter gases such as carbon dioxide, methane, hydrogen sulfide. Some of these gases can poison you, explode, replace oxygen. So even if heat didn't kill you, air would. This is one of the most terrifying real mining dangers. Rock bursts. A rock burst is when the pressure in deep rock becomes so intense that the rock suddenly snaps and explodes. It can throw rock fragments like bullets. This happens in deep mines today, even at small depths. Now imagine the pressure deeper inside Earth. Your tunnel would not be a quiet place. It would be cracking, groaning, shifting, collapsing, and sometimes violently exploding. Earth is not a dead object. It is an active, pressurized planet. So now we understand something important. The problem is not just digging. The problem is that Earth will destroy the tunnel. Heat, pressure, water, toxic gases, and rock bursts make the journey impossible. But now comes the final question. Because even if you could never dig through Earth, this thought experiment reveals something shocking. We live on a thin shell above a planet that is hotter than the surface of the sun. So why aren't we burning? In part 5, we'll answer the final truth. Why Earth's surface stays cool, while the inside is a furnace. Let's start with a fact that sounds impossible. Earth's inner core is about 5,000 to 6,000 degrees Celsius. That's similar to the temperature of the sun's surface. And yet, here we are. We walk on grass. We drink cold water. We feel winter and summer. So how can we live on a planet that is basically a giant furnace inside? The answer is one of the most important ideas in Earth science. Heat does not move upward quickly in solid rock. Imagine a burning hot oven. Now imagine that oven is wrapped in thick insulation. The inside stays extremely hot, but the outside stays safe to touch. Earth works the same way. The crust and mantle are not perfect insulators. But compared to air or metal, rock is a very poor conductor of heat. So the heat inside Earth leaks out slowly. Very slowly. Not in days. Not in years. But over millions and billions of years. That's why Earth can remain hot inside for so long. Heat moves in Earth using two main methods. 1. Conduction. This is direct heat transfer through solid material. Rock conducts heat slowly. So conduction alone would take an incredibly long time to cool Earth. 2. Convection. This is the slow circulation of hot material rising and cooler material sinking. The mantle does convection, but it happens extremely slowly. Even though mantle rock is solid, it flows over long time. This slow movement drives plate tectonics, earthquakes, mountain formation, volcanoes. So Earth's heat is not trapped perfectly, but it escapes in slow motion, like a planet-sized lava lamp operating over millions of years. Now we can answer the big question clearly. Could humans dig through Earth to the other side? In real life? Crossmark no. Because long before reaching deep layers, Heat becomes deadly. Pressure crushes tunnels. Rock flows and closes holes. Water and steam cause destruction. Toxic gases make survival impossible. Even our deepest drilling 12.3 kilometers barely scratches Earth's crust. To reach the other side, you would need to go 12,742 kilometers, Earth's diameter. That's over 1,000 times deeper than our best drilling. So the real conclusion is, Earth is not a place humans can enter. It's a planet we can only live on the surface of. So the next time you look at the ground beneath your feet, remember this. You are standing on a thin shell. Below you is a world of crushing pressure, moving rock, molten iron oceans, and a solid core hotter than the sun. We are not living on Earth. We are living on the surface of a giant hidden machine. And that machine is still running. Still producing heat. Still shaping the planet. And still reminding us that Earth is far more extreme than it looks. If you enjoyed this video, like and subscribe. And comment below, would you jump into a gravity tunnel if it existed?
Subscribe info Beyond Borders now for more mind-blowing knowledge.